So we have the present talk titled Lunar Occultation of Stars, and it will be delivered by Professor Rupa Raviprasad. She is currently a professor in Department of Mathematics at Global Academy of Technology in Bangalore. She has been working in the field of Indian astronomy for the past 1 decade. She has presented papers at various conferences and published a few papers in the Indian Journal of History of Science and other journals. She has worked on INSA research project Occultation and Transit in Indian Astronomy, Mathematical Analysis. She has co-authored the books of Bharatada Suprasidha Ganita Naru, famous Indian mathematicians. And she has also authored publications jointly with Dr. and Professor S. Balachandra Rao, Eclipses in Indian Astronomy, Transits and Occultation in Indian Astronomy. Professor Rupa Raviprasad has an MSc from Bangalore University and a PhD from Anna University, Chennai. And her doctoral thesis was Planetary Modes in Classical Indian Astronomy in comparison with Ptolemaic, Copernican and Keplerian model, a mathematical analysis. So I welcome Professor Rupa for delivering her talk.
Good morning all, and thank you Jayant sir for your kind introduction and giving me an opportunity to present at this FDP. Today I will be presenting some interesting features of lunar occultation of stars. Am I audible?
Yeah, you are audible.
Lunar occultation of stars. Yeah, okay, sir. As we all know, occultation means covering. So, occultation is complete obscuration of the light of an astronomical body, most commonly a star, by the moon. So, in Indian astronomy, siddhāntic texts have discussed in detail the phenomenon of conjunctions of the sun, moon, the planets, between any two of them, as also with some important stars like Rohiṇī, that is Aldebaran, Tiṣya, in modern terms is Delta Cancri, Makhā or Regulus. Another important star in Indian astronomy is Agastya or Canopus. It is the second brightest star, which will not be occulted by the moon as its latitude is greater than 6 degrees 21 minutes. So the phenomenon of one body covering another is discussed in the chapter called Grahayuti in most of the classical Indian texts. This takes place when the longitudes of the two concerned bodies are equal and their latitudes are in permissible limits. So here is a shloka from Surya Siddhanta, which I am not going to recite. I will just tell you the meaning of this. Slide is not moving. Sir, are the slides moving, sir? Jayant, sir?
Yeah, no, slides are not moving.
But it is moving for me here. I can scroll. I'm on the third slide.
Yeah, now it moved.
Now it's okay. I think it should be in this mode only. If I put it on the
second slide was not visible. Can you just go back one slide? Yeah.
So in Indian astronomy, the siddhāntic texts, they have discussed in detail the phenomenon of conjunctions of the sun, moon, and the planets, and between any two of them, as also with some important stars like Rohiṇī, that is Aldebaran. Tiṣya in modern terms is Delta Cancri, Makhā or Regulus. So we have another important star called Agastya or Canopus. It is given great importance in Indian astronomy, and it is the second brightest star, as we all know. This star will not be occulted by the moon as its latitude is greater than 6 degrees 22 minutes. So the phenomenon of one body covering the other is discussed in the chapter called as Grahayuti in most of the classical Indian texts. This takes place when the longitudes of the two concerned bodies are equal and their latitudes are in permissible limits. So here is a shloka from Surya Siddhanta which describes the same as follows. I am not going to recite the shloka, I will just explain the meaning of this shloka. This shloka means the moon can occult a star only when it actually covers, as in the case of a solar eclipse. And the procedure is similar to that of a solar eclipse. So occultation, lunar occultation of stars by moon, the procedure of computation is similar to that of computing a solar eclipse, except here moons are the stars are fixed here in this case, and it is similar to that of computing a solar eclipse. So early astronomers, Indian astronomers, have distinguished between 4 different possibilities of conjunctions as the solar and the lunar eclipses, which we all of us would have witnessed. Then moon covering one star or planet, star or a planet called as samagama, or the occultation. So one planet covering the other called Jyeṣṭhā, which is a very rare phenomenon to happen. And the sun covering a planet is called asthamana, that is heliacal setting. This heliacal setting is not the day-to-day rising and setting. It is different from the day-to-day rising setting. In heliacal rising and setting, the star rises and sets along with the sun. In the case of inferior planets, Mercury and Venus, they pass in front of the sun as dark spot, which we call as transits. So now I would like to discuss some historical references of conjunctions before going into the occultation, periodicity, circumstances to the modern thing. I would like to discuss the historical references of conjunction. Conjunction of Jupiter with star Tiṣya or delta Cancri is historically important. It has references in Vedas, in Rig Veda, Taittiriya Brahmana, and also in Vishnu Purana. The conjunction of Jupiter with Tiṣya, there are 7 dates from 893 BC backward up to 4048 BC. And in the last one, moon joins Jupiter and Mercury on the 4th of June around 12 noon. And this event is used to date Rig Veda by B.G. Tilak in his Arctic home of the Vedas. So these events, conjunctions and occultations, are very important, and generally they are used for dating purpose. So Indian astronomers are very fond of computations of conjunction of Rohiṇī with moon. And we have a reference of conjunction of Rohiṇī with moon in Mahaƙavi Kalidasa's Abhignana Shakuntala. Kalidasa is famous for his similes. In one of the similes, he gives an occultation of Rohiṇī by the moon, as we know, moon is called, Chandra is called as Rohiṇī Priya. Kalidasa gives a very interesting allusion of conjunction, says Rohiṇī has got conjoined with the moon and at the end of lunar eclipse. This astronomical event is used for dating of Kalidasa, who belonged to the 5th or the 6th century. It is very interesting that there was a total lunar eclipse on November 8, 542 CE, November 8, 542 CE, at the end of which moon does enter the asterium of Rohiṇī. So using this astronomical event, it was dated that Kalidasa belonged to the 5th or the 6th century. And the entry of full moon to Rohiṇī at the end of this total lunar eclipse is surely not a very frequent occurrence. It happens once in hundreds of years. So then other references of Shukra, that is the planet Venus, coming in conjunction with the Yogatara Kritika, that is Alcyon or Eta Tauri, is also given importance. It has got mentioned in Shataprata Brahmana. In fact, this event had occurred on 14th April 2020. 14th April 2020. Recently it had happened. 14th April 2020, around 6 hours 15 minutes AM, this event had occurred from our computations. So we had programmed this using the Indian classical procedures and verified these details. So the event had happened on 14th April 2020, around 6 hours 15 minutes AM. This phenomenon repeats once in 8 solar years, during which period, Venus completes 13 revolutions. Venus will complete 13 revolutions. These are some historical references of conjunctions given importance, and they are used for dating purpose. So occultations are of two types mainly: direct occultation and grazing occultation. In a direct occultation, moon completely covers the star for a few minutes. But in a grazing occultation, as most of you know, the star undergoes a series of disappearances caused by the lunar mountains. Okay, and the later one is of interest and has got a lot of research opportunities. It helps in determining the heights of lunar fractures and the depths of lunar valleys, determining if the star is a single star or may have close companions, etc. And during one of the stellar occultation on March 10th, 1977, astronomers unexpectedly discovered the rings of Uranus. So earlier, the direct occultation and grazing occultation. So they are occultation with one object. So we have double occultations also occurring, and which is very, very rare, extremely rare events. Okay, so in double occultation, the moon can occult multiple celestial objects. So the last event of such type was on 23rd April 1998, when moon occulted Venus and Jupiter. So you can see from my computation here, the longitude of moon, Venus and Jupiter are almost the same, around 114 degrees at 6 a.m. IST. And during the first millennium, that is 1000 years of the calendar, there was only one such double occultation of Venus and Jupiter on 16th of August 567. So even on that day at 1 p.m. IST, from our computations, we found that the longitudes of moon, Venus and Jupiter was 348 degrees. In the course of a sidereal period of 27.32 days, moon has conjunction with every star. Even though there is a conjunction, it may not be occultation. As we all know, every full moon and new moon will not result in an eclipse. Every conjunction need not result in an occultation. A lunar occultation of a star turns out to be an occultation only. Lunar conjunction turns out to be an occultation only when their latitudes are sufficiently close. That is one of the conditions for lunar occultation. The latitudes should be sufficiently close, and only those stars whose latitudes south or north are less than 5 degree 8 minutes are eligible for occultation. Most of the Indian classical texts, say Bhaskara's Karna Kutuhalam or Ganesha Daivagna's Graha Lagavam, Ketakiya Graha Ganitam, all these texts considers the latitude to be less than 5 degree 8 minutes. But as modern day students, we know the moon's orbit is eccentric and it can extend up to 6 degree 21 minutes. So all stars lying in that range also are eligible for lunar occultation. Thus, the visible stars which are eligible for lunar occultations are Makhā, Citrā, Rohiṇī, Kritika, Jyeṣṭhā, etc. So here, this is a shloka which gives the condition for lunar occultation of stars. So I'm not going to recite. I'm not a very good student of Sanskrit. I will not be reciting this, but I just give the meaning of the shloka. The shloka says the difference in the longitudes of conjuncting bodies is divided by the difference in their daily motion if they move in the same direction, or by the sum if one of them is retrograde. As stars are considered to be fixed, lunar occultation of a star mainly depend on the difference in their latitude. So as modern day students, we can understand the condition for lunar occultation from this slide. Suppose beta and B are the latitudes respectively of a star and the moon. and pi is the horizontal parallax of moon, S is the semi-diameter. Then the condition for occultation will be the absolute difference in the latitudes should be less than the sum of the horizontal parallax and the semi-diameter. That is, mod of b minus beta should be less than pi plus s. So here I am trying to compute the minimum and the maximum values of latitudes for occultations to occur. So here the slide gives the minimum value of the minimum and maximum value of the horizontal parallax and or the semi-diameter. So when I take the sum of these two values, the minimum turns out to be 1 degree 8 minutes 22 seconds and maximum turns out to be 1 degree 17 minutes 53 seconds. So here I just want to make a note that Bhaskara takes the value of the horizontal parallax of moon as 1 minute. So the lunar occultation of a star of latitude beta will be certain. It will definitely happen if the difference in the latitudes is less than 1 degree 8 minutes 22 seconds, and it will not be possible if the difference in latitude is greater than 1 degree 17 minutes 53 seconds, and it will be a doubtful case if in case the difference in the latitude is in between these two values. So now coming to the periodicity of occultation cycles of stars. So it is estimated that a star whose latitude is less than 3 degree 56 minutes has 2 series of lunar occultation during a sidereal period of the moon's node, that is 16 years, around 16 years.
18.
So around 18 years, around 18 years. And for stars whose latitude lies between 3 degree 56 minutes and 6 degree 21 minutes has only one series of lunar occultation. And those stars whose latitude is greater than 6 degree 21 minutes is never occulted by the moon. And that's why the star Agastya will not be occulted by the moon, as its latitude is 60 more than 6 degree 21 minutes. So here is a table which gives the series length of occultation and the interval between successive beginnings. See, once this moon starts occulting a star, that occultation period continues every month for a certain period, and then later after it is after the end, again for few months the occultation will not be possible. It will be just only the conjunction. See, for example, for star Makhā or Regulus, whose magnitude is 1.34 and latitude is 0 degree 27 minutes 53 seconds, the series length is 1.4 years. That means, for example, if the star Makhā starts occulting from this month, continuously for 1.4 years there will be occultation, and after which the occultation cycle will be stopping. And similarly for star Citrā, the occultation series, there will be continuous occultation every month for a period of 1.5 years. And for Anuradhas or Delta Scorpii also, there will be occultation for 1.5 years. And for the star Uttarashada or Delta Sagittarius, the occultation period will be 2 years approximately. So here this table gives the beginning and end of occultation cycles. We have computed from our program the beginning and end of occultation cycle. This table is for the stars whose latitude is less than 3 degree 56 minutes. See, for star Makhā, I have 2 beginning and end here. So first one I've considered is which started January 7, 2007 and it ended May 12, 2008. So during this period, January 7, 2007 to May 12, 2008, every month the moon occulted the star Makhā or Regulus. And then from 2008 to 2016, the occultation was not possible. It was only just conjunction of the moon with the star. And on December 18, 2016, again the series began. The moon started occulting the star Makhā, and it continued up to 2018 April 24. So from this you can notice the difference between the two beginnings. What I had shown in the previous slide is around 9.8 years. So here also we can notice from this slide the difference between successive beginnings of star Makhā is around 9.8 years. Similarly, star Citrā. The previous occultation cycle was from 2012 January 28 and up to it continued up to 2013 December 27. The next series will be in 2024 and it will start on June 17th, and after that every month up to November 17, 2025 there will be occultation of the moon with the star Citrā or Spica. Now you can see from this for the star Anuradha or Delta Scorpii. So occultation has started. Occultation will be starting from the next month. So now we are in 2022 February. So 2022 March 23rd will be the beginning of occultation of star Delta Scorpii. From that month onwards up to 2023 August 24, every month we can notice the occultation of Delta Scorpii. Okay, and now the last star I've considered is Uttarashada or Delta Sagittary. So right now the occultation of this star is happening. So it had started on March 8, 2021, and it will be continuing up to next year February 17th. So now these months, every month if you observe, you can notice the occultation of moon with the star Delta Sagittarius. So here I have tabulated just to demonstrate that occultation will be a continuous phenomena from beginning to the end. See, I have selected few dates of the occultations of star Makhā, which started 18th December 2016 and ended on April 24, 2018. So previous months also we have computed, and then the later months also we have computed the difference in latitude and verified that the occultations will appear. So you can observe here in the month of November 2016, so on November 21st there is a conjunction of moon with the star Regulus or Makhā, but it is not an occultation as the latitude difference is 1 degree 26 minutes. So we have seen the limits for occultation to occur so in the previous slide. So here the limit what we have obtained is 1 degree 26 minutes, hence the occult which is more than the permissible limit, so occultation will not be possible. And in the very next month, December on 18th at around that was Sunday, around 23 hours 23 minutes when the moon's latitude was 0 degree 31 minutes south, the difference in the latitude of the moon and the star is 0 degree 99 minutes, which is in the permissible limits, and the occultation occurred. So here after that every month there was occultation. Here I have computed for alternate months. I could not fit in all the data here, so I have computed for alternate months. So every month after that occultation was possible, and it ended on 25th April, which was Wednesday at 2 hours 19 minutes. The occultation occurred when the moon's latitude was 1 degree 38 minutes north, and the difference in latitude 1 degree 17 minutes. So the very next month later to that, we can see the difference in the latitude is 1 degree 42 minutes from this table, and since the difference in latitude is greater than 1 degree 17 minutes as we have observed in the previous slide, occultation will not be possible. So the next occultation series of star Makhā will start in the year 2025. So 3 years from now, 2025, in July 27, the occultations, next occultation star of star Makhā will begin. So this, I just wanted to verify our computations, and so I've just verified it using the software Stellarium. So here for the date 18th December 2016, which was the beginning of occultation cycle of Makhā. So at 23 hours 24 minutes, we can notice that the procedure developed by Dr. Balchandra Rao sir, my guide, and it's exactly coincides with what we obtained from the Stellarium software also. So here it's a beautiful picture of moon occulting the star Regulus, and this is a very close occultation, I can see. So then we have also computed occultation series for series which will happen from 2020 to 2120 for the next 1 century. We have programmed and computed the dates of beginning and end of occultation cycle, and also the difference in latitude and etc. All required parameters we have computed, and we have used the procedure, Indian classical procedures, and also improved procedures as developed by SBR sir. So here this table just gives the occultation cycle of star Makhā from 2020 to 2120. So we can notice here during this occultation cycle there will be at least 18 occultations in one cycle, and 18 to 20 occultations in a cycle. So number of occultation, if you when the occultation which will start from 2025 and which will end in 2026 will have 20 occultations. 20 months in that period there will be occultation of the moon with the star. So this is the table we have. I have computed for star Citrā or Spica. So the next cycle will be starting on June 17 next year. So here even this star has approximately around 19 to 24 occultations during a cycle of occultation. So this is the table for star Anuradha. So right now, as I mentioned earlier, occultations of star Anuradha is going on every month. You can notice the occultation of this star, and approximately around 18 to 23 occultations will be possible during a cycle of occultation. So then next category we have is the stars whose latitude is between 3 degree 56 minutes to 6 degree 21 minutes. The star which comes in this latitude limit are Kritika, that is Alcyon or Eta Tauri, Jyeṣṭhā, and that is Antares or Alpha Scorpii, Rohiṇī, Aldebaran, Agni, Beta Tauri. These are the 4 stars I have computed and studied. So here Kritika, Jyeṣṭhā, Rohiṇī, and Agni. The latitudes and the series length I have given here, and these stars will have only one series during the sidereal period of the moon's node, whereas the earlier star whose latitude was less than 3 degree 56 minutes had 2 series in the sidereal period of the moon's node. Here they will have only one series, and the duration of occultation cycle is larger in these case in these 4 stars. So which earlier slide we have noticed the duration of occultation cycle was 1.9 to 2 years approximately, but for these stars whose latitude is 3 degree 56 minutes to 6 degree 21 minutes, the occultation duration, that is once the occultation begins till the end, it will be around 5 years. 5 years continuously occultations will be possible. 5 years, and for some stars it is 3.5 and 3.7 years also. So this table gives the occultation beginning and end of the stars whose latitude is between 3 degree 56 minutes and 6 degree 21 minutes. So here right now I think from the slide, occultations of these stars are not happening. So occultation of Rohiṇī is ended on September 3rd, 2018, and for the stars Kritika, Jyeṣṭhā, and Agni, the occultation will be starting from the next year. From the next year, once it starts continuously for around approximately 5 years, occultation will be possible for star Kritika, and for 3.5 years, occultations of Rohiṇī will be visible. So again, this table gives the computations of beginning and end of occultations of the stars which lie in the latitude range of 3 degree 56 minutes and 6 degree 21 minutes here. So, and we can notice that here during an occultation cycle there will be approximately around 48 occultations possible for the star Rohiṇī. And this table gives the occultations of star Antares or Jyeṣṭhā for the next 1 century. So the next series will start on August 25th, 2023, and it will continue up to August 27, 2028, approximately around 5 years. And then after that, up to March 14, 2024, there will be no occultation of the star. And once it starts, it will continue up to 2047 and so on like that. So this is tabulated for the next 1 century. This table gives the occultations, first and last occultation of star Kritika. So right now, occultations are not happening for this star, and the occultation will start on September 6th, 2023. Next year, the occultation will start, and continuously for 79 months, there will be occultation of this star by the moon. So here I have an interesting example which I have collected from Epigraphia Carnatica volume 9, and it mentions the date April 13, 1233, Shalivahana Shaka 1156. So this inscription records Moon, Aldebaran, Venus, and Mercury were in a group. So we just try to verify this, and the following are the results which we have noticed. This example is can be also considered as a freak case of occultation. So freak case we can discuss. There are some freak cases. Between occultation, a particular month occultation may be missing, or during a month of no occultation, a particular month can also have an occultation. So those are freak cases which I'll be discussing later, some of them later. So now here this example recorded in Epigraphia volume 9, which we have found in Epigraphia volume 9, I have used here for discussing the free cases of occultation of Rohiṇī. So this is, this inscription records Moon, Aldebaran, Venus, and Mercury in a group. So when we computed the longitudes of the Moon, Venus, and Mercury, we found that they were very close on this day. But actually the occultation of Rohiṇī was not possible on this day. But in fact, occultation was possible. Actual occultation of star Rohiṇī was possible only on 11th January 2034. So this period occultation was not possible. So the actual series started on 11th January 2034, and but in on September 24, 1233. So occultation was possible between the months where occultation was not happening. So this is a freak case. In the month of August 1233, occultation was not possible since the latitudinal difference was 1.23 degrees, and whereas in the month of September, very next month, September, latitude difference was 1.14 and occultation occurred. And in the later month October, the occultation was not possible as the latitude difference was 1.18. So this was a freak case of Rohiṇī occultation. So just to verify this from the software, I collected this image, and it's a very beautiful image where we can find the moon, the star Aldebaran, Venus and Mercury, all of them in conjunction. So this is for the date 13th April 1233 as recorded in Epigraphia Carnatica. Okay, so as I mentioned, we will be discussing some freak cases of occultation, doubtful case, how to calculate the doubtful. So in the previous slide, one of the slide I had mentioned that the occultation will be doubtful if the latitude difference is between mod of E minus beta lies between 1.1 and 1.7 degrees. So those cases we have discussed here. So the lunar conjunction of star Citrā during the year 2013, every month turned out to be occultation. On the other hand, the subsequent year 2014, the first conjunction on January 23rd was a case of probable occultation, while none of the rest during that year was an occultation. So these are some freak cases which we have worked out. Similarly, during the year 1993, between January and September, none of the conjunctions were occultation, but the case of conjunction on October 15th and 16th was a probable case of occultation. So here the same I have tabulated in the form of a table here. In the year 1993, November and January, there was no occultation of star Citrā, but whereas in the month of November and January, occultation was possible, whereas in the month of December, occultation did not happen. And again, for the star Kritika in the year 2010, we can find freak case here. So in the month of October 2010, there was occultation. Now the very next month, November, occultation was not possible. In December, occultation happened, and then in the month of January, there was no occultation of the star. So this is a very freak case to happen. So our calculations we just tried to verify from the Stellarium software. So for the first example, that is 19th November 2012, we can notice there was occultation. The moon and the star Spica are very close, in close conjunction. Whereas the very next month, we can notice from the picture the conjunction was not close, and hence there was a difference in latitude and occultation did not happen. So the same I have computed for or verified for the star Kritika or Alcyon, and verified our result. See, there are some many historical references of occultation of bright star. So here is a list of some occultation, starting from Democharis of Alexandria, who records an occultation of Beta Scorpii on December 21st, 251 BC. So from BC to 1883, an example given by Venkatesh Ketkar for the occultation of star Spica we have discussed discussed here, and I have just tried to verify these results and found that the event happened, and from our computations we could notice that the results given what we get obtaining what we obtain from our computations are almost very close to the results or the values or the dates and the timing given by the astronomers. So this example of Democharis, Democharis has been he has recorded his observation of occultation of star Spica, which happened on March 9th, 293 BC at Alexandria, about 4 sessional hours before midnight. And when we computed using our improved siddhāntic procedure, we found that the results were true, and as in the case of solar eclipse, here also we computed the instant of external ingress, middle, and the external egress of the occultation, and found that the timing was almost coinciding with the timing what was recorded by Democharis. So this is another example given by Agriappa, a 1st century astronomer. He records his observation of lunar occultation of the star Pleiades, which took place on the night between 29th and 30th November 92 CE. Okay, the brightest star in the group corresponding to Alcyon, and when we verified the conjunction of the star and the moon was around, instead of conjunction, was around 22 hours 19 minutes IST, and here we have computed the beginning, end, and middle of the occultation of the star using improved siddhāntic procedure. So there are some more examples which I will not be going into the detail. So this is the example which I had mentioned. This is an example given by Venkatesh Ketkar, who records an observation of occultation of Citrā on January 29, 1883. So here, when we computed the following computations we could make. So on this day, the tropical longitude of moon and Citrā was 202 degree 21 minutes, around 25 hours 30 minutes IST, with the moon's latitude being minus 123 minutes, and difference in the latitude was 0.6 minutes, and it's a very close conjunction and an occultation. So since the difference in latitude is very small, it was a beautiful occultation to have watched. So this is just the verification. You can see the moon and the star in the picture is almost together. So it was a very close conjunction of star Spica. Okay, so these are some references.
Correct, still. In 5-10 minutes, another comment.
Thank you.
Yeah. So yeah.
Allah, you can get into details, and it will be exciting.
Yeah, it would be exciting if some details we can have it, some discussions, and if anybody has any questions on whatever was shown, they can ask the speaker directly. Or if you have anything, if you want to put in the chat box, you can write it there. I will read it out. So if there is no questions, I would like to thank Dr. Rupa Raviprasad for giving us the overview of the India's occultation.
Jadbabu, can I ask a question?
Yeah, please, you can go ahead.
Okay. Maybe already you have covered, and I am not due to I was absence in between for internet connection. But it was a very good talk, and my question is like what science we can bring out of this lunar occultation of star, Sorry if you already mentioned and I missed it.
What science you could bring out of lunar occultation?
Yeah, because
kind we have spoken from mathematical point of view.
Sir, we have spoken from the mathematical point of view. And computations and periodicity and all these things, and these occultations can be used for dating of the Vedas and inscriptions, etc.
Right.
Physics needs to be studied.
Physics needs to be studied. I was just wondering, like from other occultation, sometime about exoplanet and all information we can get. So from this kind of lunar occultation, whether that is possible or not.
Yeah, it should be possible. Astrophysics.
Yeah, sir, it should be possible, but we are mainly into computations using Indian.
Yeah, I understand.
So a modern physicist or astronomer would be able to tell that.
Yeah, okay. Well, I am a by profession solar physicist, so I was just curious. Thank you. It was a nice talk.
Thank you, sir. Thank you, sir.
Any other questions from anybody?
Yoga Mahesh Shetty strictly will follow what you have done.
Yeah. Yesterday he was there, so yes. Yeah. So I would like to thank Dr. Rupa Raviprasad for this presentation.